Okay, so welcome back, and now what we want to do is that we want to dive into the concept of machine learning. So what do we have? So first of all, we need a data set. For a data set, we will be analyzing the FIFA 19 data set, which is taken from a site called Kaggle. You can create your free account. It's secure, it's free, and you can get access to a lot of data sets. FIFA 19 dataset is one such data set. We will not do machine learning on this data set, rather we will just be introducing you to the concept of analyzing data for the beginners, in order to for setting the stage for machine learning, which we will do on a data set called Iris dataset. Alright, so let's get started. So first of all, I have my FIFA machine learning code open, our notebook open over here, and I'll be explaining it to you line by line, and I'll also show it to you in a new notebook, so that you can see it work. So first of all, I'll import the libraries. Import pandas as pd, import numpy as np, import matplotlib.pyplot actually as plt, and finally import seaborn as sns. Now as it runs, I'll explain it to you. So over here I've imported pandas, which is a data analysis library, as under the pseudonym as pd. So pd is basically the pseudonym, so that we do not have to write the entire statement pandas as a whole again. And numpy is called, so pd, np, plt, and sns are basically the standards, and they are the universally used standards. You can name it whatever you want. You can name it np, ns, whatever you want, but for it is a standard. It is standard to use pd for pandas, np for numpy, plt for matplotlib.pyplot, and sns for seaborn. So as we can see that it has run without any error, and we have executed the first line of code. Now we will store our data set. So you want to see your data set first of all. So first of all, we will show it in an object called the data frame. So we'll store it in an object called the data frame. So pd.read csv, and name of the csv, whatever you have named the file. So to open a csv, to upload any file, we have to go to uploads, then select the file from the dialog menu that appears, file dialog menu that appears. Now we will go to FIFA, this one, and we have successfully after it, right, we will have successfully stored the data in a object called Python object called the data frame. Now what we have done over here is that we have taken data frame, and we have we have used this command called read csv, and we have read the csv in csv, and within the parentheses we have specified the name of the csv file, which is data.csv. in our case, you can whatever in your case, whatever you have named the file, then you will get this in the documentation of pandas, which I will link to obviously in the resource, in the link below. And so we have the read csv, and we have imported the library, we have imported the data and stored it in an object called data frame. It's not a variable. In this case we call it an object. Now let's print out this data frame. Now in this Jupyter notebook, we don't have to type to print like this. We can type, in this case the data will appear clumsy like this. So in Jupyter Notebook we may or we may not type it, but over here we'll have to type it. All right. Oops, what happened? All right, so the thing that happened is, the thing that took place is that we stored it in a different file. So there is a different data.csv. all right, so let's examine data.csv. Let's see. So we find that this is data.csv. Do we have another data.csv? No, probably we don't. So what we have to do is that we have to upload it again, which is called dstt. All right, so probably install it from the website itself, Kaggle. I'll download 9 MBs. There we go, we have it. Now we will go to upload again, then we will go to where I've stored the file. So yeah, just wait. Yeah, upload. Okay, let's check it right over here. Actually it's not, it has come, but we need to zip it for Python to upload it actually. So let's do it. Let's zip it, or unzip it actually. Alright, there we go, we have unzipped it and now it is ready to be loaded. So let's see. There we go, data.csv. Actually I'll name it data1.csv to avoid some confusion like we had earlier time. So yeah, there we go. Sorry for the disturbance, but now we have the file. Let's say, yeah, there we go, we have the data. So to get the head of the data, or to get the first 4 lines of the data, or the first 5 actually, is I taught you earlier that in Python indexing starts from 0, both the columns as well as the rows, and also in a list. Alright, get the head of it. There we go, that's the head. First 5 columns actually. You can see 5 rows actually, not 5 columns, 5 rows. So there is the 5 rows. To get the tail, we can do tail like this, but now for now we'll do head. Now we can do something called data frame dot describe. This will not take any parentheses. This will not take any parentheses, as this is, if we give any parentheses, let's see what happens. Well, I was just you got me. Yeah, it takes in parentheses. What I'm talking about is the shape data frame dot shape function, which does not take any parentheses. Now if we put tuple object is not compilable, therefore it is not an object, it's not a function object, it's a built-in function. Alright, so these are the various functions, or these are the various statistical description of this data. So what do we have? We have count. So count is basically the number of items. So in this we have obviously have the same number of items. Mean is basically the total. Mean is basically a form of average where we have all the sum of the data by the number of data. So the mean here is 9103, the mean here is 2414, which means that is the sum of all the data of this column itself, of this column, divided by all the data in this column, number of data in this column. There we go. And shape returns what is the shape of this object or this data frame. So shape is 18227, so it is in the form, this is comment in Python, this is in the form row comma column. So this is in the form row comma column. And we have standard deviation, which I will teach you or dive deep into in the course on statistics. For now, let's leave it. Minimum, we know it's a minimum value in the data in the column 25 percentile. Again, I'll go into this, dive into this in statistics course. We have the maximum value as well. 25 percentile, 50 percentile, 75 percentile all have a significant value actually, and you will observe that 50 percentile is equal to the mean, or it's actually almost equal to the mean, as we can see over here. So that's suspense till I release the statistics course. So until then, let it remain in suspense. So let's go back to let's see what else can we do. We can do values to find out all the values. Data frame dot values. Can we put parentheses in this? No. There we go. So this is also not an object type. What else can we do? It returns all the values in all the columns as a list or an array. So we can apply something like conditionals. So you can type data, or I'll give df2 is equal to, or df1 is equal to, is equal to data frame less than 30 . So what do we have here? Let's see, data frame age, we have to specify the column. Data frame age less than 30 dot head. Again, I told you what the head does. Alright, list object has no attribute called head. Can we get the values? Let's see, df1. There we go. What just happened here? Well, let's take this code and let's paste it over here. So we can see a difference. We can see a certain difference. Data frame is in the whole. Again, this we can access from the documentation of Python itself. This is called list conditionals. Alright, less than 30. There we go. We get all the players less than 30 with the statistics, which is more to high, which means that it's in the descending order. So it start 92 and 91, 91, 90, like that. Alright, that's how it functions. What else can we do? Alright, we can take some columns out. So let's say df2 is equal to, let's say, data frame. We have, actually it's a function, it's called the data frame function. Data frame, we'll take the data as data frame, as we have done over here. As you can see, data frame, comma, then the columns. So in this case we have taken name, wedge, value, overall, age. Let's take that. Oops, sorry. So what do we have? I forgot this. Yeah, it's running and it's run. There we go. There we have it now. But the thing is, it's all blank. Why is it blank? Well, that's because we didn't specify the columns attribute. Now some attributes require them to be specified, or else they would not be right, or else they would not be assigned to it. So as shown in variable df3, let's say df3, there we go, we have it. So we have the name column, we have the wedge column, we have the value column, we have the overall column, and we have the age column, all in once. Alright, now this is in euros. We want to convert it into normal rupees, and we also want to remove the millions and Ks. Alright, so there's this code over here which I'm going to import over here, copy paste basically. Alright, there we go. Now if you check df3, alright, so we don't still have it removed. That's because we have to change the values over here. Is it changed? Yes, it is. Well, it's not. We have got NANs, a lot of them. There we go. Now it's done. So let me explain this code. So the thing with this code is, there is a function of value to float which takes something of type x. If type x, the type of x is equal to float, or type of x is equal to integer, it will return the x value. If k in x, or if there is k in x, then if len x is less than 1, we will return float with the whole x dot replace k with this thing, and we'll do the entire value times 1000, and then return the value times 1000. M means, which means million, we'll do it times million and replace this with this, which is empty string, and return the 1000 times the value. B means billion, and we will do the same. So here we wedge, here we have a value called wedge, we do dot replace, and we use this thing which is called regex, but it's beyond the scope of this lecture. We will introduce regex to you in a later lecture, maybe not in this course, maybe another in another course, or in the basics course. Alright, so apply value to float. We are applying the value to float. Just remember this thing, which I may send you the link to this notebook which is in Google Colaboratory, and I also also may not, all depends on whether I can actually. So but if I can, good for you, then let's do it. Let's continue. So replace with this and drag x is equal to true. So we have all of them. TF3. What else can we do? Well, we can introduce this SNS. So I'm going to type, let's type it actually, SNS.set, which sets this SNS within the scope of this thing, which means it sets the SNS to this and does not open an external website. Alright, so there we have. So we can also do something like this. We can also create something like this graph plot. So let's create it if you want to see it in action based on the values on which and value. Alright, so let's create a variable object called graph. Graph is equal to SNS, sorry, not SMS, SNS dot scatter plot, and then you would have something called the x, then the y, x coordinate, y coordinate, and then the data. So x, let's specify the x, sorry, x is equal to, in here we also have to mention it, and x here is small in lowercase, right? So x is equal to, let's say, the wedge, and y is equal to the values column, and finally the data is equal to d3. d3 is not defined, actually it's df3, cannot interpret values, so it's value. Alright, what do we have here? Oops, is it so less? Well, that's because we don't have all the values. Let's do one thing, let's do it with df2, df or data frame, and let's see what happens. So let's wait for it, let's wait for the surprise. Alright, what is this? Now, this is not something like that. This is basically, it contains so many values. It contains around 180,207 values that it cannot afford within this, which is why it has to accommodate like that. Alright, so this is the perfect one, and let's do one thing, let's introduce you to this finally to this machine learning section. So I don't have a notebook, and I'll also open ID's machine learning. So sklearn is a module from where we will import. It's a brilliant module. It is where we will spend most of the time, and it is a module which contains most of the models, most of the models actually, and most of the data sets. So Iris dataset is a very popular dataset among everyone. So we will load a dataset called Iris dataset. So let's say datasets or dataset, actually datasets, import, load iris. So this is the command required to load the iris data set, and we'll set iris. So you can see that it has run. So the iris is equal to load iris. Alright, so you can check it over here. Well, it doesn't look at all. So this is actually an array for performing machine learning. More the data looks better or worse, more with the better will be, with the easier will be the data analysis actually. So as you can see, we have a value called x, which is capital X this time, and this is get. We take this as iris.data, which is the input. So we'll specify the input. There we go. And mind you, this doesn't have parentheses. And y is equal to iris dot targets. Yeah. So we have got the target. We have got the target of the x. So as I've written over here, f of x will be equal to y, as we have seen in the first lecture. All right. Now let's print out both of them. Even I won't understand this thing. This is gibberish to me actually. This joke. All I know is that this is the training data set, or this is the targets. I mean, this is the data that we have here, the metadata or the input data, and this is the final or the the data with which we're going to test it, or the test the model that we have. So let's ignore this part, but this feature names is basically the number of the columns that we have. So every model has a feature name and a target name. So let's, for example, take the CSV actually, this one. Let's see what is the feature and what is the target. Let's identify them, both of them. So what is the feature and what's the target? Well, we can see that the country is a feature, the age is a feature, the salary is a feature. What do we want to find out? Whether the person has purchased the item or not. That's the target. So here we get, the machine does it for us. We can also do it on our own, which we will see later in further course. Actually, this is the last video of it, so maybe not the last, maybe the second last. So we have this. So we can get the feature names as sepal width, sepal length, petal length, petal width. These are the features, and these are the targets, or the various versions that are possible for it. Setosa, Versicolor, Virginica. Based on these values, it can identify these three. As we can see, all of them are numpy arrays. So we'll do something. I'll copy paste it right over here. This is called scalar.model selection and import train test split, which will split our data as we learned in the first video, which is split our data into training, test, and training and test. So it will just split X train. We have X train, then we'll specify the X test, then we have the Y train and Y test. Mind you, Y train is not going to be trained, rather it's going to be tested. So, and let me copy paste this as well. Train test split, and X comma Y should be the data. We don't have to specify it. X comma Y, and we have to specify the test size. Now you don't want your training data to be actually the test size. Mind you, it's a test size. In R you have to do train size, but here it's test size. Don't confuse them. So test size, what we have is that in test size we are going to specify the test size, which is will probably be in decimals. so there's 0.2, which is 20%, which refers to 20%. So we have to express the percentage as a decimal. So we don't want the training data to be too long, or we don't want the test data to be too long as well. For if the training data is too long, then it'll rather become a basic model, and it will rather be limited to the data itself and will not work with other data or foreign data particles, as we call them. If the test data is too long, and then the trained data will be less in proportion, and as a result the model will fail or be less accurate due to lack of practice and lack of testing, or not lack of testing. Testing will be 100% probably, but due to lack of training. So my recommended percentage for the training percentage is okay, so my recommended percentage for it is 0.8. Actually 0.2, 20%, which is probably the test size. I support which leaves 80% as the trained data, which is not large, although it may seem large. In proportion, it's not large. It's 20%. I prefer 20%. Let's see it. Let's see what a model can do with 80%. Alright, so let's run it. Alright, it run. You can see it like this. You can observe, you can watch it like this. X-train. This is the X test. This is the Y train, and finally this is the Y test. Alright, so if you want the shape, print shape, X-train. If we have X-train, then we have to as we did earlier, we have to do X-train dot shape 120,4. Alright, it's different, but believe me, it's going to work. It's going to work. So X test dot shape. If you have X test dot shape as well, 30,4. Size are different. We are seeing that it's about half of it actually, but let's proceed. So this part I'm going to copy and explain. This part, let's run it. So let's explain it. So we have some sklearn. We have something called sklearn.neighbors, from where we can import kn neighbors classifier. Kn neighbors classifier, what's that? So it's basically a model. So k neighbors classifier we call it. So sklearn.neighbors is the function from where we are importing, like matplotlib or pyplot, and import k neighbors classifier. So knn, we have specified knn, which is as an object, which is equal to, and assigned in the value that k neighbors classifier. We can classify it in neighbors or the neighbors that we have. How many data points do you need for grouping, for predicting what the value would be. So we kept 3. After much experimentation, you can experiment with it and see your accuracy. Now we have fit it with the X-train data and Y-train data, and it's going to predict the X test. Alright, now we are going to test it with Y test, right? So there is something called accuracy testing. For that we need to import from sklearn. Let's do it by hand. From sklearn, import metrics. Alright, so this is another module of sklearn. Now print accuracy.meterscore. Sorry, metrics.accuracy score. So we'll print the metrics dot accuracy score and give it the values y test. So it's going to test y test comma y prediction. So are you ready for the result? So before that we first imported metrics from sklearn, and then we specified matrix as the accuracy score and y test and then y prediction. What do we get? 1 is 1 is 1 the metric score, that accuracy score that we get? Is it? Well, not. Well, it's not. Then is it 10? Well, if we ignore the point, is it 10? Well, it's not. Then if you do 10 squared, then you'll probably get the answer. Yes, it's 100%. It predicted it itself 100%. Well, it's the same thing as the percentage. So what is 100 percentage? Well, 100% is 100 by 100, which cancel out, and we're left with 1 by 1, which results in 1. There we go. This is the perfect model that we have. Let's see for ourselves whether it's correct or not. This is the y test data, and this is our prediction. These are our predictions. You can see for yourself that it's perfectly correct. So this is done after much experimentation. Don't go by this. Maybe your model will come 9.6 with this. This varies from computer to computer and from data to data. So, and it also depends on whether your model was good enough, whether you did the right test size, right? So what we can also do is that we can use another model which is the decision tree classifier. So let's import them from sklearn.tree here. So decision tree classifier, which is another model. So then we have specified DTC is equal to decision tree classifier. Good news, we don't have any parameters over here within this curly braces, or whatever we call the first brackets. So this is, we have fit it just like the last time. Everything is like the last time. We tested with the prediction 19, right? Now we'll copy this again and paste it. Oh god, that's quite nice. We have got 100% again. Let's test it on the X data and give it to Y test. Alright, what happened? Well, we can't change the shape. It is assigned a shape. We can't change the shape. Y test is of another shape. X test is of another shape. Therefore, we can't change the shape. Alright, so there we have. Last time we got prediction of 9.33333, and here too we have got a prediction of 1 at first, then 9.33. Alright, can we save the model? Yes, we can. So learn dot externals import what we call joblib. So alright, so joblib, so model, so we have specified the model is equal to joblib dot load actually joblib dot dump. Let's copy this code, right? Alright, so we have, all right, let's explain it. So sklearn to the rescue again. It has another section called, another module called externals, which has another function called joblib. Now we have saved this, we have created an object class called model, and we use joblib to dump this model called knn, which is the earlier model, and we have set it iris.ml.joblib or ml1. Actually the last time we saved it in ml, so this time we have to save it in ml1. So there we have it, ml1. Alright, there's a warning. What is the warning? There's no warning, fine. If there's no warning, then it's fine. Let's load it. Actually, let me copy this to another file. Let me select another, open another Python 3, and let's put it to the test. Alright, knn is not specified. Alright, it's going to work in actually, let me just do this. And see, yeah, it ran. It has run. Now let's test it. Let's put it to the test. So load the data set first. Load the data set. Secondly, we will do the train test split. X is not defined. Alright, did we miss a step? Probably yes, we did. Iris is not defined. Sorry. Alright. So there we go. Extraneous test. Alright, now we don't need to do the steps as we've already done it. We have to do this step, then insert below, and now we will do this step. Yeah, so we'll set it to Y prediction and we'll set it. Let's test the accuracy. There we go, 0.966667. As I told, it varies from computer to computer and from file to file and from dataset to dataset, and we can see over here earlier last time we got 1 with this model, and this time we got 0.96, which is 96% or 97%, depending on whether you round it off or not. So that's basically it of data science, and finally I'll show you the steps. So let me open machine learning. Alright, so let's see what are the steps. So first, importing the libraries, which I missed, but I showed you, right? So importing the libraries, then importing the data set, which is the step that we did over here. Taking care of missing data we did not do, but let me show you. Over here we have some things called nan. We don't want that. What do we do? We simply use something called nan and one hot encoder. What do they have? Well, not that. We use something called simple imputer. Again, sklearn to the rescue. Now simple imputer takes in missing values is equal to np.nan. Now in numpy, np is numpy as well imported. np.nan strategy, let us specify the strategy in which we want, standard deviation or mean or maximum, whatever we want. We in this case we are mean, right? So impute.fit, we have fit the value into the column. We'll show you how to change the column in the course of statistics. For now let's leave it, just pass through it, and there we go. We have filled the nan values with the mean of the data. So that's taking care of missing data. Encoding categorical values. Now categorical values we can encode, we can set them to numbers 0, 1, 2, 3. For example, over here we have specified them as binary digits, as you can see, 1 and 0. Alright, so encoding independent variables and dependent variables. Now this is basically separating independent and dependent variables, and finally, as we did, splitting the data into training data and testing data. Then feature scaling, which is something I'll show you again in the statistics lecture and is beyond the scope of this lecture. Then we apply a model like we did, then we get the predictions, and finally we test the accuracy. So thank you very much for staying up this course, and I hope you liked it and learned something from it. Thank you.